Lesson 11.1, Task 1. Previously, you learned that two quantities x and y show direct variation if x equals ax, where a is not equal to 0. Two quantities x and y show inverse variation if y equals a over x, where a is not equal to 0. The constant a is the constant of variation, and y is said to vary inversely with x. All right, so direct variation, y equals ax, this is something that we've studied with linear equations. This is like a linear equation with a y-intercept of 0, and a would just be the slope. So that's why it is a direct variation, okay? Inverse variation is something new, so it's going to be y equals a over x, where a is not equal to 0. And the constant a is just a constant, what it said. So it's just considered the constant of variation. So y is said to vary inversely with x when this happens. Okay? All right, so Amelia walks for exercise on 2 consecutive days. Her walking speed r on day 1 and the distance d she walks on day 2 are shown in the photo. So day 1, it says her rate is 4 miles per hour. So that's her speed, and that's a constant speed. So that would be considered direct variation. It would be consistent or constant. All right, day 2, she has a distance of 6 miles. So it doesn't say if she's walking at the same speed or not. Okay? All right, so it says write an equation giving Amelia's distance d, walked on day 1, as a function of time t that she walks. Is the relationship between t and d direct variation or inverse variation? All right, so for day 1, she has a rate of 4 miles per hour. So that's going to be 4 times however much time goes by. And the relationship between t and d is direct variation. All right, what happens to the distance Amelia walks on day 1 if her walking time doubles? All right, if her walking time doubles, she covers twice the distance because she has the same rate of speed the whole time. All right, so it says write an equation giving the time t it takes Amelia to complete her walk on day 2 as a function of her walking speed r. Is the relationship between r and t direct variation or inverse variation? All right, so if you look up here above, okay, her distance on day 2 is 6 miles per hour. All right, so her distance is 6 miles per hour. So the equation is now going to be 6 miles, and then whatever her rate is. All right. The relationship between r and t is inverse variation. Spelled it wrong. All right. All right, what happens to the time it takes Amelia to complete her walk on day 2 if she jogs at double her walking speed? All right, if she goes twice as fast, she will go, it will take her half as long. So it's inverse related, okay? So if instead of walking, she jogs and she doubles her speed, that means it would take her half the time to do the same distance. All right, if you have any questions about task 1, please let me know. Lesson 11.1, task 2. All right, so we're going to investigate graphs of inverse variations. The inverse variation function f of x equals a over x is defined for all non-zero real numbers x. However, in this lesson, you will be looking at real real-world situations in which the domain is restricted to positive numbers and the constant of variation a is also positive. All right, so the graph of f of x equals 1 over x for all x greater than 0, so that means all positive x. As x approaches infinity, what happens to the value of f of x, or your y value? All right, so this is talking about your end behavior. So let's just look at what this looks like. So if we go to y equals, and we graph y equals 1 over x, and then we're only going to be looking at the positive x's, so for x greater than 0. So we're only going to look at the right side of the graph, which let's go ahead and make our window back to a 10 by 10. If we do zoom 6, that takes you back to a standard 10 by 10 graph. Okay, so only going to look at this side of the graph right here, all the values that are greater than 0. All right, so it says as x approaches infinity, okay, as x goes to the right or approaches infinity, y approaches 0. It approaches the x-axis. All right, it says what is the horizontal isotope of the graph? Okay, so here's the horizontal isotope. So this is y, so it goes through y at 0. All right, then it says as x approaches 0, okay, so here's 0. So as the graph approaches 0, it looks like it's going up towards the y-axis. So as x approaches 0 from the right, f of x approaches infinity. And again, we're only looking at the right side of the graph, so we're only looking at this piece of the graph right here. All right, so it says what is the vertical isotope of the graph? Okay, if you look at the vertical isotope, it goes to x at 0. So this would be x at 0. And then it says the graph of f of x equals 1 over x, 2 over x, and 1/2 or 0.5 over x are shown. How are the graphs alike and how are they different? Well, you can see that all of the end behavior is different, which means your isotopes are going to be the same, but the difference is they're all a little bit different distance from the origin. So like where they turn, that's where the numbers being different kind of make the graph different. But they all have the same isotopes and they all have the same end behavior. All right, if you have any questions about task 2, please let me know.